late, that's no big deal. So I'll just get started. Don't have a ton of time here, so I'm just going to get going. Yeah, so I'm Ben Geisler. I've got sort of an introduction on the next slide here. But I'm going to be talking about a new game programming language I'm making for UE4. And I'm hoping it's going to be used as a balancing tool, essentially. So these are my current affiliations with, this is being done as part of a doctorate at Southeastern, which is in Florida, actually. And I teach at University of Wisconsin, Green Bay. My contracting company is Thought Codebase, which used to be Frozen Codebase, and now it's Thought. Really bad at it. But anyway, and so I'm currently contracted with Institute, which is a drone company. Oh, thank you. So excited to be giving this talk. I've been working in the industry 17 years. Creating games professionally. I worked at a bunch of Wisconsin-based studios. I worked at Raven, Human Head, Frozen Codebase. I also worked at Zymo, which is up in Green Bay. And I love making games. It's been really quite a ride these 17 years. Mostly I've been a programmer. So I've done a lot of AI programming. I've done a lot of systems programming. Actually, speaking of the language thing, I actually once at Raven I imported Python onto a PS2, which was quite a challenge. So I've done quite a bit in the scripting and gameplay side of things. So mostly I'm a programmer. I've done some production things. I've done a little bit of game design, especially at Frozen Codebase. These days I'm teaching, but I'm also earning a doctorate, and that's sort of what this talk is about, because I was successful in my quest to get someone crazy enough to give me a doctorate in video games, basically. So I'm going to talk about how I managed to pull that off. And that's essentially what this is about. So I'm hoping it's a useful tool eventually, but if ultimately it was something a vehicle essentially to get my doctorate, and hopefully it also turns out to be useful for practitioners. So all right, so the motivation for what I'm doing. Basically, UE4 is really powerful. Put this in for you, Joe.
Thank you. Unreal Engine 4.
What's that?
It's not Unreal 4.
Oh man, I got it right on the second line. Yeah, I'm not consistent in my slide here. But more importantly, Unreal Engine 4, it's got its own C++. It's got blueprints, and more recently, it's got the Skookum script plugin, which is Agog Labs makes their own scripting language for it. So there's like at least 3 different ways to do things, which is great. You know, we can do logic diagrams and blueprints. We can do code in C++. We can do all kinds of things with UE4. That's awesome, but the question is, where am I supposed to put stuff? What is the guiding factor of how I'm supposed to do stuff? And obviously, one of the powers of UE4 is you get to choose, but with that choice, as they say, comes great responsibility. So I mean, we got to figure out essentially where I'm supposed to put all this balanced code. This current solution that a lot of people do, which is perhaps the wrong solution, we can talk about maybe alternates to doing things the way I'm going to propose, but the current solution for a lot of games is let's put it everywhere. Let's throw hit points in as a property off of an object. Let's throw jump heights in as some sort of variable on a node graph in blueprints. Let's put in weapon damage to C++ for whatever reason. And heck, while we're at it, let's import Skookum, and then we can have rate of fire inside of Skookum. You know, and that's what we see a lot of times, unfortunately. That's what I've seen a lot of times when I've been on UE4 games. Now, granted, a good portion of the UE4 games I've been on have been game jams. So, you know, those are going to be a little bit more hack-fest than the kind of games you make in a production setting where hopefully you're a little more organized in your approach. But still, even if you're very organized, you're going to end up with balanced code that's sort of all over the place. Ultimately, though, how important is game balance? Game balance is huge. And so we're taking this approach, and this is sort of my opinions, and you know, here I am on a soapbox basically talking about why does this matter? Why are we sort of not treating this as a first-class citizen? It really should be, because if you think about it, when you look at esports, when you look at StarCraft, when you look at StarCraft 2 versus StarCraft, the original one, or even look at how influential that is and still is, a game made in 1998, and the fact that esports is still relevant, you know, especially basically I forget this guy's name, but he's like the Korean champion of StarCraft, which means a lot. So game balance is huge. Bad balance, obviously, we know about good balance, right? We know that, okay, if you've got a well-balanced game, especially in the esports sector, you can probably do really, really well, like League of Legends, Dota 2, that kind of stuff, and single player for that matter, it's very important for. And we also know what bad balance leads to. It leads to games that aren't going to sell. they're just going to give undesirable results. And so we don't want this. We don't want bad balance. So obviously, balance is important. So obviously, if it's such an important thing, that means we've got conferences about it, right? Kind of like SIGGRAPH has a conference on game rendering. We must have a conference on game balance, right? We must be able to hire game balance engineers, right? Like just people that just are devoted to that, right? There's probably plenty of books. Well, the case is that's not true for any of this, really. I mean, kinda. I mean, there are books written about this subject. It's not totally devoid of any sort of progress, but it's certainly not a first-class citizen in the sense that computer graphics are to video games, or AI is, or something like that. It's sort of a, bastard stepchild that is super important, it turns out. So I'm sort of saying, well, let's take a look at how we do balance and really think about that from a tech perspective. Not really from a Ralph Kostner sort of look at how game balance should be done, but more from a tech perspective. So the obligatory quote I have here is, just because you can do something doesn't mean you should do something. So just because you can use UE4 to put your balance code all over the place doesn't mean you should do it. It's great that you can. I don't necessarily think you should. This is a quote that the first time I ever heard this quote, this is not even an attributable quote because everyone says this, but the first time I heard it was when I was learning to be a DJ when I was 17, and I had a train wreck mixed with Alpha Team and Lords of Acid, and it was just a nightmare disaster. And the guy that was mentoring me to be a DJ said this to me, and it's just sort of stuck with me. Just because you can do something doesn't mean you should. So how do we do game balance? Well, we can study the works of all these theoretical folks that talk about it, like Robin Hunicke, Eric Zimmerman, Ralph Kostner, Theory of Fun, he wrote, Warren Spector. I mean, there's a lot of people that talk about game balance. There's great work out there, such as the M+DEV, which is Mechanics, Dynamics, and Aesthetics. For example, in that framework, they break it down. Robin Hunicke and her cohorts sort of broke it down to say that mechanics is low-level things like hit points and the actual variables that are making up game balance, and then dynamics is how all of those hit points and sort of, if you think of those as like a matrix, how all of those relate to each other and create sort of a dynamic environment just based off those variables. And then at the higher level is aesthetics, the idea that the dynamics are going to give way to a feeling that the player has, such as that level really sucked, or that level was awesome, or whatever they're going to use to describe that experience they just had. So M+DEV stipulates that there should be a fine balance between MD and A. Players should be challenged just enough, essentially, to have just enough, just get by the level or whatever, just enough. There's a fine line there, basically. And so it's going to be a really hard thing to capture. And for that matter, it gets even more complicated because, as they wrote in their work that's sort of now famous in this realm, is that there's different player types. There's different archetypes, and different types are going to require different types of balance. So for example, it's all about getting this balance right. And this spectrum, this graph, is going to look different for different player types, but really, ultimately, you're all trying to capture, everyone is going to have to capture that sort of central channel where you want the challenge to be just right. You don't want it to be too difficult. You don't want it to be too easy. You want the player to feel like they're challenged. And ultimately, a lot of this gets back to what actually Warren was talking about in his keynote, which is I got into games because of D&D as well. And some of those early sessions playing Dungeons & Dragons with DMs that would be able to, the thing about D&D is if the DM is sensing, the Dungeon Master is sensing that the players are either not having fun or they're about ready to check out or whatever, they can make adjustments on the fly. Ultimately, a lot of my research is leading towards how we can make on-the-fly adjustments. I don't feel like we're at that stage yet as an industry from a technical perspective to make really good, informed, on-the-fly decisions like a human can that's DMing a game. But I do feel like we can at least start with that, with some of the game balancing stuff that I'm sort of proposing. So ultimately, it's all about kind of like what he was talking about. It's getting back to playing a game with your friends and how that goes about. The problem is, doing this from a technical perspective, doing it all programmatically is very hard. Let's take an example of an action game. I'm going to start having to flip through some slides here pretty quickly, I think, because I'm going to run out of time. But basic idea is in said action game, it was third-person action. We can assume it's single player. we collect things, we shoot things, typical action game, whatever, right? We assume it's single player. Well, even if you take a typical action game where it's maybe a military themed, shooter or something, there's still, as simple as that is, as you have to get through the level, maybe you have to do some sneaking, whatever it is you have to do, you've got a ton of things you got to balance. You got to balance the hit points, you got to balance the speed, the maneuverability, the defenses of the player, the weapons of the player, and then you have to do that for every single enemy in the game. What I sort of found that I was doing my research was that, well, board game creators do a ton of this. They, on paper, they do their balancing. I've never been a board game creator. I mean, I've tried to make some amateur before I became a professional video game programmer, but I just see this happening a lot. They have these charts, such as this. This is a chart that's showing, and you can't really read it, but it's showing the weapon to hit. These are each weapon, and this is what you need to hit. It's sort of like a 2-hit armor class sort of table. And this is the damage that you cause, random variable damage that you cause. And this is sort of the percent you have of hitting at each one of those levels of the weapon, and the weapon can be upgraded over time. That's what you need to hit on a D6 from that number of squares away. So this is 1 square away, 2 squares, 10 squares. And so, for example, the shotgun, it might be easier to hit from up close than it is from far away. And that's just one example, and I mean just one little particular thing about weapons for the player. It's just part of the story. In reality, there might be 5 guns, that's going to be 60 possible values, and that's just talking about guns. Says nothing about the fact that there's other types of characters and all that stuff. So it gets complex. This is from SimWar, showing various factors related to this particular RTS game, where, like, if things are purchased, this is the cost of the purchase to build like certain units, and then what are the attack values of those units. I mean, there's tons of numbers in a video game. It's obvious, right? So the problem is, what I'm trying to tackle here, now we're finally getting to sort of the solution part of it, is this is all really just a big, elaborate spreadsheet. Unfortunately, spreadsheets might not be the best solution either, but I'll get back to that point. The number of shots might be a property, 2-hit values might be a property, etc. The key problem I have with a spreadsheet is, what if we want to tune it quickly between play tests? What if we want to try a bunch of players out and give them the game, have them try it, and then we want to very quickly iterate on that. And where I'm going to is eventually automated balance, but for now I'm sort of proposing that it'd be nicer if we could quickly make modifications to those level variables based on player feedback, like very quickly, not sort of a long delay where basically the playtest results come in, the lead designer takes a look at them, goes to his office, closes the door for a couple days and just spends time on a spreadsheet, turns around, gives that to the programmers, and they have to go and implement it. It's just that process is kind of a long process. I want it to be design driven. I want the person that's in charge of that, the lead designer, or maybe other gameplay designers, to be able to have the power to make those adjustments on the fly without having to rely on programmers to do it. So I'm essentially making a design language is what I'm proposing. So basically the idea is, we could, now there's multiple solutions to this. We could just say, forget it, we're not going to use C++ blueprints, properties, and Skookum, we're just going to choose one. So fine, you could do that, that's true. But I would argue that in that case, if you're just choosing one, you're really losing some of the power of Unreal Engine 4, which is the power of expressivity, the freedom of choice, all those other wholesome American values that we know and hold dear. Really, you're giving developers an incredible amount of power in giving them all those possibilities, and now we're taking them away, essentially, going back to, Quake-style programming or something like that. But seriously, it's really good it can be good to constrain developers, but it also can be sometimes bad. The DJ, his name was DJ Sunshine, yes, I'm not afraid to admit. The guy that told me this in the 90s when I was DJing, just because you can do something doesn't mean you should. He's not always right. It's not really a black and white issue. Because really, you're kind of looking for a silver bullet at that point. You're looking for one overall engine. And Rick Johnson, my former lead at Raven when I first started, he was at Valve for a while after that, and now he's doing some other fancy things. He said to me once, there's no silver bullet to game design, and I've also held that true, seen that to be true over the years. And I think it's not a black and white situation. So we really need the ability that maybe in certain situations, C++ is better, in others, Blueprints is better. it's as simple as that. It's like you're going to have tasks that just are meant for one language or the other. Other problems with choosing one language might be that sort of none of these languages are perfect for designers. Even blueprints require access to the editor, which is fine. I mean, that's not a big deal. But you do end up needing tribal knowledge as well as where all these things are and which blueprint file and et cetera, yada, yada. So this is where I'm proposing a meta language. And a meta language, so first of all, is what the heck is a meta language? We don't have a ton of experience we haven't used a ton of meta languages in the game development arena. It's basically a domain-specific language. Examples are Template Haskell, Lara, Spectacle, Awesome, Ruby on Rails, that's the one I'm going to show. A lot of these are academic concepts that haven't really made their way to mainstream programming yet, but they can be very powerful languages that can essentially generate code from another language. I want to combine that with aspect-oriented languages, which are things like AspectJ, PostSharp, and Fadi, which are basically solutions to have one centralized place for any particular concern, which is, for example, balanced code. And so aspect-oriented languages help you, and I'll come back to this in a second to explain fully what aspect-oriented languages are, but they essentially help you to swallow things up into one common place. There's a term called monkey patching in Ruby on Rails, and it's very hard to read this, I think, but it basically is a function called gibberish defined here inside of the class. And this function says put s myAmazingSentence.gibberish. And what it does is it essentially takes gibberish and puts that as this string. So this definition of gibberish is going to replace whatever this is, essentially. So it's going to write out its own version of what the actual output is. So you're effectively changing how a string operates based on, this is Ruby on Rails, and it's sort of you're modifying the function based on some outside method. You could kind of think of it almost as a lambda in that sense. Monkey patching can be a bad thing. Altering behavior of function causes obfuscation. It can cause confusion. It's not always necessarily a good thing, but what I'm arguing is that from the point of centralization, it could actually help us. The other big piece to this puzzle is aspect-oriented languages, which came about in the early 2000s. It allows programmers to say, do cross-cutting concerns, basically. So if there's multiple places in a code base that are doing things, and they're all the same things, for example, logging, memory allocation, spawning, all of those things could be wrapped together into one aspect. And essentially that aspect, so if like these classes are doing the same kind of things, class foo and class bar, if they're both doing logging, for example, or they're both doing memory allocation, create an aspect that knows that they're doing those things, and inside of that aspect, it has code that responds to the fact that they're doing that thing. This is an example GameSpec grammar that I'm working on, or not grammar, an aspect for GameSpec. This is the language that I'm creating. So it describes an aspect here, and this one is called declare point cut die. This one is declare point cut decrease health. So anyone that calls decrease health will call this function. So it's a method of code injection, essentially. It lets you call this function from the fact that decrement health was called. So now anyone that's calling that can call subtract health on it, or can call decrement health on it. So you can imagine that this could be inserted into blueprints, it could be inserted into Skookum, it could be inserted into C++, and then we'd have one central point where everything sort of comes together. And that's sort of where I'm going to. The goals and next steps, what I'm working on now, and I've got kind of a little bit of it's really not a prototype yet, but it's just proving that I think some of this will work. Basically, GameSpec would sit on top of the 3 UE4 languages. It would be an open source plugin for UE4 is what I'm hoping for, because obviously this is an academic work as opposed to a financial endeavor. So it would be open source, which is part of the details I got to work out. But it would sit on top of these 3 as its own language that would essentially generate Skookum, C++, and blueprints. The main use case would be this, that a developer would code the game as normal using C++, Skookum, and blueprints. Then the developer at some point would use this. There's another tool that I found called the Source Navigator, which is essentially like an automated UML generator. That would allow the developer to find the join points that they care about, such as when the health is decreased, or when the jump span is increased, or whatever, physics, mechanics, health, damage. Then the developer would annotate where those points are in the code, and that would be exposed in game spec where they could furthermore than change those values. And so the use case would be, there is some human effort here. This isn't a fully automated process. The human is gonna have to go through those UML diagrams and say, okay, I want this health thing from Blueprints and this jump thing from C++ or whatever, combine those all together, and then you get to what I showed here, which is now that we've combined all those, we can influence and say what the values are gonna be. So this would be what the designer would have, basically, is the game script code that just says, okay, the firing rate is this, the whatever is this. I'm suggesting the programmers would essentially go through here, or maybe with the designers, identify those join points, and then that's their use case. This is the source navigator tool I mentioned, also open source, and this, in case it was creating a UML chart for a asteroids game, where there's like a enemy, a missile, asteroid, and each of these have various values that could be used for balance, like health and life and fire rate and stuff like that. I'm using Xtext and Xtend, which are modern professional level language building tools. They're built, unfortunately, on top of Eclipse, which I'm not really enjoying working with, but they allow you to make grammars. So this is the game spec grammar. And those of you that might have studied programming language would probably recognize sort of the Backus-Naur form sort of format of this, you know, where we're sort of defining things in terms of other things, attributes and whatnot. You can't really see it there, especially from the back row. But it's basically a grammar, just as any other grammar you define, kind of like a context-free grammar or something like that. So it allows that, which is really cool. I don't have to do the full compiler from the ground up. I can use Xtext and Xtend, which again are open source tools. I'm also going to use a product called TXL, which is also open source, which allows for code injection. So once the join points are found, I can transform the Skookum script in C++. I'm still working on how to do the blueprints, because blueprints, technically they're called from C++, so that's what I'm planning on doing, is calling it from there. But I got to look into that yet. I haven't proven that out yet. Anyway, this function here, it says construct an expression which does sprintf foo. This foo is going to be added to every function call of this form. So this is an exec_p function call in C++ that's called just possible underscore command. And TXL actually automatically inserted sprintf foo as the first call to it. So this is how far I got with it. I created language and I did this, and now I can prove that essentially I can add code to that C++, which is where I want it to be at, because that's essentially what I need to do to be able to pull this off, is code injection. And then game script or game spec could actually advise basically this C++ code and this blueprint code. As far as progress, and I'm getting near the end here and then I can take some questions. The basic grammar has been created. I showed just a really quick snippet of that. My next step right now is now code transformation, which basically I'm going to, for this, I'm planning on, this might change, but for now, I'm planning on transforming the code, because game spec code itself needs to be able to have variables and be a proper language to some degree, so that it can hold things such that if events happen, it needs to know about those, etc. So I'm thinking of doing that in Skookum, because I've been working with them. I got an academic license for Skookum, and it's not open source, but they do provide the code for me. I got to work that out, because if I'm doing this as open source and then Skookum isn't open source, so I got to work that out. This might end up changing to C++, which is okay. I mean, that doesn't prevent my research. It just, I'd rather do Skookum. And then basically the TXL experimentation, I showed you that's sort of started. And that's about it. So yeah, questions? Oh, we at 5? Perfect, good. So yeah, that's, you can always email me at ben@thoughtcodebase. Thoughtcodebase is just it's not really, it's just a consulting company basically. We're not actually actively doing any big projects or anything, but I just thought that's sort of where all my email goes to. So you can do ben@thoughtcodebase. And my goal, we'll see where I'm at next year, because I want to get this PhD done. I got to get this to a ready state that it actually works. So my goal is to have it done in about a year. So just started about a month ago, so we'll see how it goes. The process for a PhD is interesting in that they don't expect you to do that much before when you make this proposal. I couldn't stand that, because I want to know that this is actually possible. before I started. So I did start some work to actually prove that I could start it, but that's where I'm at. So any questions? No questions?
Well, I kind of.
Yeah, go for it.
I don't know if it's relevant or not. So we're artists and we're a small company.
Okay.
And our coder is in
Yeah, Bobby's with you,
Yeah,
right?
we're Bobby's company. So he does things in blueprints and then converts them to C++ because he finds it cleaner and just better for our game in general. We're morons and we have no idea. But I was just kind of curious if you thought that was the right thing to do because it kind of, I don't know if it bothers him for whatever reason it does, but he just converts it all to C++ and that's what we get.
Well, first of all, I think we're all morons for doing what we do, but
Yeah.
we're all crazy somehow, right? But
we're not code people, so we have.
yeah, no, I know what you're saying.
I'm
So
running the game.
you're asking like, should he be translating it to C++?
It seems legitimate to me. It seems like a good thing to do.
Yeah, I mean, I think it could be like, I know that it's been argued that C++ is potentially faster. I don't know if I buy that because Blueprints is native, so it shouldn't be I'm not totally sure I buy that. In the sense of networking, sometimes I know it matters, but
correct me if I'm wrong, but isn't that put there for usability for people who aren't, he's a software engineer, he's who we brought in, and
Right.
that's how he's worked for 15 years.
in C++.
Yeah.
So
I
it's a
think-
usability. He's used to C++.
Yeah, and
So
I
yeah.
think blueprints are easier for people who are newer to coding.
Right,
But for
I
an
agree.
experienced engineer, he's just like, well, it's.
I mean, I remember I was in a UE4 demonstration years back when they were first announcing it, and I saw blueprints, and you could put like breakpoints in there, which you couldn't do back in Kismet, and I was like, holy crap, this is gonna be awesome, and it turned out to be awesome. But
The kind of epic pitch we did it, hashtag not an engineer,
yeah.
is converting everything natively to C++ as your default. You lose the flexibility of quick changes.
Yeah,
to
yeah,
things.
yeah.
What we do is he does it in blueprints and he sends them back to us, and then once we've kind of decided, he basically says he exposes the variables that we'll need, and then he just converts it over.
Okay, that's fine. He might be doing some work in his need to, though. We find that blueprints are performant enough in most cases where you don't need to go.
That was kind of my question, is it gonna clog up our game if we have a lot of blueprints versus C++?
I've heard arguments that I kind of buy about networked games,
Yeah,
but I'm not sure. Like single player, I don't think it really.
it depends.
Yeah.
So what we tell developers is build your game in blueprints, then do profiling to see where your bottlenecks are and
Right.
convert those things to C++.
So he might be going overboard doing every single
Probably.
one.
But, some teams do that.
Well, that's the thing. That's the point I was trying to make. Is some teams they're going to do whatever works for them, which might be a good thing, but also is kind of bad because you kind of want, as a designer, you're going to want like one central place where you can be modifying stuff eventually.
Well,
It's really, I'm looking at it as another tool, and I'll honestly, if everyone just goes blueprints, that's fine. It's, I'm not saying this is like the be all end all, but it might be a useful tool for designers to use to tweak their games. Any other questions? Oh, all right. Well, are we good? We're good? Okay. I guess we're good. Thank you.